Hello geometers and general seekers of truth. In this video I'm going to show you how to make a triangle using a compass and straight edge only when given two lengths this time and one particular angle. So we must have an angle of this size and we must have these two lengths. The other angles, the other side lengths, well, that's up to us. So this time what I'm going to do is start by replicating the angle first. And I'm going to call this angle A, I'm going to call this point X and this point Y. Now X and Y aren't really that big a deal. I'm just making it so that we have something to talk about. Right? So first thing that I'm going to do is put a point somewhere on my paper, and I'm going to call this point A. Right? And in fact, I am going to extend this line here. So it goes in any direction. We'll worry about how long and where to cut it off a little bit later. So now I'm going to replicate this angle. And hopefully from the previous parts of the notes you know how to replicate an angle. If not, that's okay. So we're going to set the needle on A, the pencil on Y, transfer it over, make a mark. Okay. So this is basically Y. I'm not going to write it in here because I don't want it to get too cluttered. And then we are going to set the needle on A, the size of this point here on X, and I'm going to transfer it over and make an arc. So now I know that X has to appear somewhere on this arc. We don't know exactly where yet, but it must appear on this arc. So in order to pinpoint it, we need to get a intersection. Right? So remember that one of the key things about constructions is finding intersections. That's how you pinpoint. You know for sure where to put certain points. So we're going to set the needle of the compass on Y, the pencil on X, and then transfer it over here and replicate. So at that intersection is exactly where I am going to place point X. Excuse me. So now I know that this angle here is precisely congruent to this angle here because I constructed it that way. Now, the hardest part of this is over. The easier part now comes into play when we just replicate the segments. So I'll call this segment here AB, set the needle on A, the pencil on B, transfer it over, and make a mark. So wherever this arc intersects that line, or that side length, that's going to be point B. And finally, the last segment here is going to be AC. Set the needle on A, the pencil on C, transfer it over, and draw an arc along here somewhere. Now I know that the point C must appear somewhere on this arc, but I don't know exactly where. Well, it's not too difficult because I know for a fact that in order for this angle to stay true, we have to extend it until it hits that arc. Okay? So wherever the arc intersects with this line extension, that is the location of point C. Now we just take our pencil or a straight edge and connect those two. And there you have it. We've basically completed the construction. So I know that this angle here is equal to that angle because we made it that way. I know that AC is congruent to this AC because we made it that way. And finally, I know that AB has also been properly copied. So that segment and this segment down here. And so there you have it. We've completed what we set out to do. Now, what I want to address here is, can we make another triangle that is not congruent to this one? Can we make another triangle that is not congruent to this one? So in order to do this, I'm going to do this on wax paper just so that we can compare it and match it up to the other. So what I'm going to do here is something maybe a little bit different. I'm going to try to start out with making AB instead. So put a dot on here. We will label this point A. Put the needle on A and the pencil on B, and then transfer it over. Okay. And I'm going a little fast here because I am presuming that you've done this before and you know how to replicate some of these things. So we're going to extend or draw a segment from A through the arc, and we're going to label that point B. So because we made it that way, we know for a fact that AB here is congruent to the other AB. Then what I'm going to do is replicate this angle right here, but instead of replicating it over here, I'm going to replicate it over here. All right, so just to mix it up a little bit this time. So we're going to put the needle on A, the pencil mark on X, all right, needle on A, pencil on X, transfer it over, and I'm going to make that, I'm going to replicate this angle off of B this time. Okay, so this is the location of my X, right? And again, I'm not labeling that X just because I don't want to clutter the picture. Then the needle on A, the pencil on Y, needle on A, pencil on Y, transfer it over, and draw this arc here. So now I know that Y must appear somewhere on this arc. To pinpoint it, I'm going to put the needle on X, the pencil on Y, needle on X, pencil on Y, and then do the same thing again. Ooh, I came just close enough. All right. Long enough in order to make that happen. So now, using my straight edge, I'm going to make this connection. And I have this angle down here, angle B this time, congruent to angle A. Excuse me. So I'm trying very hard to make a different triangle, and by different I mean non-congruent. And the very last thing that I'm going to do is set the needle on A, the pencil on C, and then needle on B, and draw this arc right here, and extend this point, this segment from B up to there, and put a dot there, and that's going to be the location of point C. And then finally close it out by drawing that line, last line segment. So this line segment BC is congruent to this segment right here because I made it that way. Okay, just to be clear, BC here is actually congruent to AC up here. Right. So it seems that I have worked very hard here in order to make a different triangle. But yet, if we just kind of rearrange things a little bit there, you can see that I end up with the exact same congruent triangle that I had before. So I had the triangle that we made, and then I had a triangle that I tried to make a different way, but because of the way that I made it, it actually turns out to be exactly the same. So it seems that there is no possible way for us to make a non-congruent triangle, at least not this way. So if you notice in the first example, the angle joins the two sides. In this example, the angle also joins the two sides. So when you have that case, there is no possible way for you to make a second non-congruent triangle. So this is worth noting. When a fixed angle joins two fixed sides, only one triangle can be constructed. And by fixed here, I mean unchanging. We're not changing the size of it. And when I say one triangle, we mean one non-congruent triangle. Of course, these are two different triangles, but yet they are exactly the same size. Let me see how I got this. They are the exact same size and the exact same shape. So they're essentially one triangle, even though we made two of them. Right? But before I leave you, I will give you a little teaser in that using these three pieces, we can actually make 2 additional triangles. So be sure to watch the next video. Thank you for watching, and have a wonderful day.